I will start with very simple matter and we'll go to very complex conditions also. Okay, look at this. This is the series combination of resistors in which resistors are connected in to in with each other in such a way that when we pass current from one end, the same current passes through each of the resistors. In this combination, total resistance between these 2 points A and B, we can say this is A, this is B. The total resistance between AB can be calculated by using this equation R. Total resistance R is equal to R1 plus R2 plus R3, and if there are more, then they can also be included. This is the formula to calculate total resistance between AB. It was proved in previous class. If you have noticed, I proved this in previous class. Now another method, I mean to say, this is another type of combination. If one end of each resistor is connected to a common point, another end of each of them is connected to another common point, then the combination of this resistor is called parallel combination of resistor. In this case, potential difference across each resistor remains same, but current divides among these three branches. And if we have to find out the total resistance, then we can use this formula 1 by R. R is total resistance is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. If there are other also, we can use this. It means reciprocal of the total resistance is equal to sum of the reciprocal of each of the resistance. And this R1, R2, R3 are the resistance of each of the resistor. Here also the resistance of each of the resistor is R1, R2, R3. They are different. This way we can solve the numerical one. These are very easy method of solution. Now let's go to a little different. If we have this type of combination, how they are connected, here one resistor is given and other two are here. We can name them as resistance R1, this is resistance R2, this is resistance R3. This is a little different than the previous. Total resistance can be calculated this way. First, we have to be very clear these two are in parallel. That's why if we calculate R dash, then 1 by R dash in parallel combination, the reciprocal of the total resistance is equal to sum of the reciprocal of individual resistance. 1 by R dash equal to 1 by R2 plus 1 by R3. This way what we get after the calculation, we will get R dash. Now this R dash, which is the total of this R2 and R3, is in series with this R1. That's why total resistance R is equal to the R dash plus this one R1. This way we can get the solution. I mean to say we can solve this numerical problem. Okay, now look at this another one. Let's say this is R1, this is R2 and this is R3. Now what is the equivalent resistance between these two points, total resistance between these 2 points? Now looking at this diagram, you can understand easily this and this R1 and R2 are in series, but these two are in parallel with R3. That's why first we have to find out the R dash. R dash is equal to R1 plus R2. And when R dash is calculated, then we can calculate, but R1 and R2 are in series, but this series combination is in parallel with R3. That's why when we get R dash, then total resistance 1 by R will be equal to the reciprocal of 1 by R dash and reciprocal of 1 by R3. This way we can calculate what? R resistance. This second problem can be solved. Now look at this third. If this is R1, this is R2, this is R3 and this is R4, then how do we get the solution? We can get solution this way. These two are in parallel. That's why we can name R dash is equal to, now reciprocal of R dash is equal to reciprocal of what? R1 plus reciprocal of the R2. And this way we can calculate what? R dash. This is we have now. Now in this case also they are in parallel. So the reciprocal of, let's say this is R double dash is equal to 1 by R3 plus 1 by R4. And putting the value we can calculate here R double dash. And if these two are found, then they are in series with each other, because the total of this is R1, total of this is R2. That's why, therefore, we can calculate R by the help of these two. They are in series. That's why R dash plus R double dash. This way, we can get the solution. Okay, let's go to another also. A little more complex. Let's go to another a little more complex. Look at this. This is a condition given. And if the values are given, then we are not using value, we are not interested with the answer, but we are interested with the method. This is, let's say this is R1, this is R2, this is R3, this is R4, and this is R5, and this is R6. Looking at this, it seems to be a little complex, but this can be solved easily. We have to start with the far corner from the equivalent points. I mean to say far corner from AB. Here R2, R3 and R4 are in series. This can be understood very easily. In series combination, what happens? We can say R dash is equal to R2 plus R3 plus R4. Thus we can calculate R dash. Now, once R dash is calculated, then this R dash is in parallel with this R5. So, what can we do? This R double dash, it is better to write this R double dash. They are parallel to each other. That's why R double dash is equal to 1 by this R dash and this 1 by R5. This way we will calculate what? R double dash. Now what is left? All these are added, and lastly we have R double dash. Now this R double dash and R1 and R6 are in series. Therefore what can we say? Total resistance R is equal to this R1 plus, and the sum of this is already calculated, R double dash plus R6. This way we can calculate what? Total resistance R between these 2 points. I mean to say equivalent resistance between AB. And now there is another also. Look at this numerical problem. Here what is given? It seems to be a little difficult, but when we put the symbol, then we will be a little comfortable for this. This is, let's say, R1, this is R2, this is R3, this is R4, and this is R5. It seems to be difficult, isn't it? Now R1 and R2 are in series with each other. R4 and R5 are also in series with each other. This is positional problem only. Look at this. If it is turned like this, then you can understand very easily. This R1 and R2 are in series, and this total of this is in parallel with R3. But R4 and R5 are in series and parallel with R3. That's why what can we do? First, the series, let's say R dash is equal to R1 plus R2. Now we'll get R dash by the help of this equation. And then the another one, look at this, R4 and R5. R double dash is equal to R4 plus R5. Then here we'll get R double dash. Now these two are in parallel with R3. That's why we can calculate by using this equation. Now R, this 1 by R is equal to, now 1 by R dash plus 1 by R double dash plus 1 by R3. This way we can find the total resistance. Okay. Now let's talk about another also. This seems to be a little difficult, Look at this. Now I want to name each of the resistance of each of the resistor. I want to give the symbol. This is, let's say, R1, this is R2, this is R3, this is R4, and this is R5. We have to find out the equivalent resistance of this AB, the total resistance between AB. Now, how it is possible? It would be better to start from far away from these terminals. Look at this, R2 and R3, they are in series, and this series connection is in parallel with R4. That's why you can do like this: R dash is equal to R2 plus R3. This way we'll get R dash. Now next it is parallel with R4. That's why we can say, now another name we can select, R double dash is equal to R dash 1 by R dash plus 1 by R4. Now this much is solved and it gives what? R double dash. Now we don't need this R dash also. Now this R double dash, which represents the total of these three resistors, resistance, now it is in series with R1 and R5. That's why what can we say? Therefore R is equal to, here we have R1 and plus, this is in series what? R double dash plus R5. Look at this. This is the method of finding the correct way to solve the numerical problem. Don't scare with all this. It seems to be very difficult looking at once, looking at glance. But if you think about this carefully, these are very easy numerical problem. You can solve it. Okay, this much for today.